Good morning, everyone. I hope you are starting great with a good day. So, today's topic in AI, IoT, and ML is fun with functions. So, yeah. So, first, what are functions? So, what are functions in programming? So, a function is a block of code made up of all set of steps and results in a single specific action. Yeah. So the programmer will be give this action a simple name. Giving a simple name to a function increases the chance that the set of steps can easily be talked about and reused again and again in the program. So if we have a same type of function in the program and we have to reuse it again and again, so we just simply create a function in my blocks. So I'll just show you. We'll go to PictoBlocks and then block coding. So here in the left corner we will find my blocks, which is in pink color. So whenever we are making a function, we have to click on make a block and let's see how it works. So here we have an example. So it is start, do addition, input 15 and 20, output result is 1. And print result, do addition, inputs are 20 and 40, output result is 2. Print result 2. So this is, here we will find a similarity in doing an addition. So whenever we are doing an addition, we will take 2 inputs from the user and we just add by using one addition operator. So we'll create a function named addition and we'll take 2 inputs. Inputs are A and B. And the function is sum equals to A plus B. And then return to sum. And we have one activity in PictoBlocks. So you'll understand more when you do hands-on. So please follow while I'm doing on the stream. If you have any doubts or if my audio is not up to the voice, and you can just tell me in the chat box. Just pop out. Yeah. So yeah, functions in PictoBlocks. In PictoBlocks, we execute the functions with custom blocks. So we are customizing a block. So as I told, here we will find my blocks option, and here you have to click on make a block. So here it will ask you to enter the block name. So if it's an input and number, we can select this input text, boolean expression, or just a label. So these are the types where we can create multiple types of functions. So here click on the button make a block, a pop-up will open. Now you can enter the block name you want to give it. So let's make it send message and click OK when done. So here sending a message is mostly a text, right? So we'll click on display message. And then the block will be created like this, and the text is the output, so we'll take the output later. So display message in text, or you can directly make a block like like this also. So it will just take one single block. So if you want to add it anywhere in the program, so functions are something we create beside the program. So we give a function and we use that function in the program. So here we can write some blocks of code, and then we use this defined function in the program. So let's see. Yeah, my camera is yeah, now it's visible. So here we have to take say for 2 seconds block below the define message block and add the message block when the green flag is clicked. Let's see. So here we are programming for Toby. Make sure you have one character on your stage, and here we'll go to say block for 2 seconds and display hello for 2 seconds. So this is the function that we are creating, and now we'll go to events. When flag is clicked, we'll take our display message function and put it here, hello. And if you want to change the message, you can change. Like this. Yeah, and we have one more activity, function with parameter. So what are different functions with parameter? As we discussed, we'll have the variables accepted by a function to perform the set of tasks defined in its body are called function parameters. So types of acceptable parameters in the PictoBlocks are numbers, text and boolean. So this is the last one is by default. So calling a function with a single parameter and create a block with text input. So here we have to take one text input. So greeting and a name. We have to take greeting. We have to create a function with named greeting, and we have to take the output as a name. So here we are taking input from the user and take that answer, putting it into the function. So here we have to greet someone who is the like whatever the input we are getting from the user, we have to take that block as an answer. So let's see. So let's make another block to add text. The block's name will be greeting and the text is name. Yeah. So now here we have to say hello and the name. So we have to take one join expression, join operator. So in the looks will take say for 2 seconds. We'll take one join operator, join apple and banana. So here we'll create one I'll just do good morning, and then when flag is clicked, we'll take our greeting here, or we'll go to sensing, ask what's your name and wait. Then we'll take the greeting, put our answer here, and we have to take, go to my blocks, we have to take this name here. good morning and the name. So let's run the program. So it's like good morning Johnny. So here we have to add one more space because it's not. Let's see. So this is how it works. I guess you are following up. If you're not following up and you are finding any difficulty, please let me know in the chat box, and try to make do the program with me here, so that you'll have no doubts. Yeah, and this is the output you can see in the PictoBlocks. So yeah, now properties of a circle. So we're having one more activity here. So this is advantages of function R. So it increases the readability. So it makes code organized and easy to understand, and reduces the code length. So as a programmer, we need to make sure that we are writing an efficient code with less number of lines, so that it will be easy to debug, and also it reduces the space that is occupied by the program in our RAM. So redundant code is removed and replaced by the function. So that's how it reduces the code length. And reusability is also there. So code can be reused multiple times here itself. While writing the program, it will be easy not to do multiple times. So area and perimeter of a circle is the activity. So let's create a program that asks the user to enter the radius of a circle and calculates the area and the perimeter of the circle. So here we know the formula of area. It's pi multiplied by radius, which is pi r square. So pi, we know the pi value, it's 3.14, and 2 radius square, the inputs square. So it is multiplied by itself another time. So radius into radius, and perimeter of a circle is 2 pi r. So it's like 2 multiplied by pi value 3.14, and the radius is multiplied by this value. So let's take a block and create a radius, and we have to take the number input here, because for area and perimeter we'll just take number, right? So the radius, which is our input, it's in number, so we have to create one. So let's do it. So here for area, say area for 2 seconds, pi multiplied by radius, and result. So that's how it is created. Let's create. I'm deleting this code. Make a block with the number input. This is called area, and this is radius. Again, we need one more number input, perimeter, and this is radius. Okay, we know that we have to go to say hello. Even here I'll take the same thing. Take join block 2 times. Now it's visible. Okay. We have to take one more join block. So here we are just multiplying, we are not. So 3.14 into radius into radius. Now we'll take another save block. Here we can just take the operator asterisk multiplication pi r square 3.14 radius so here you can add one more join, which is area equals to and for perimeter 2 pi r. I'm going to duplicate the same block here. So here 2 pi r for 2 seconds. Now this is our function block, so these functions are ready. Now let's do the program. So when flag is clicked, ask to enter the radius and wait. Take the answer for perimeter and the area. So go to events when flag is clicked. Go to my blocks, area. So first we have to ask for the input. Ask. So enter and wait. So we'll go to my blocks, take area and the perimeter here, and we'll take the answer and put it in area and perimeter, and then we'll change a little. So I'll just put one baseball background so that it will be. So enter the radius of a circle. Let's test 5. So the area is that, and this is the area 7.85, and it is 31.4 is the perimeter. So if you want the answer to be displayed a little longer, you can just put increase the seconds. So 85, and this is the area of a circle, and the perimeter is 533.8. So this is how we create. So you guys please save the project whatever you're doing, so that will be useful for you later. I'm just deleting it because I need the screen to be open, so you guys can save. So the save option will be here. So whenever you click this, it will directly save in the downloads, or whether, and you can change the rename the project in the folder. You can just go to the folder and downloads. You can just rename like area and perimeter. So like this. So your code will be saved. If you, whenever you double click open this, or you can import the files from file, load from your computer, area of a perimeter, and it will replace your current project. Let's see, it's the same. Yeah. So let's move on to the next topic. So this is like a question where can a function return a value. So consider here, you have to consider a scenario wherein we calculate the square of a number using a function, calculate the cube of another number using another function, and then add the result generated from these two functions and print them. So this is the function program for it. So square of a number, just this is nothing but just a pseudo code. You can just refer it like a pseudo code. No other language is there. So square of a number is input 1. We are taking input from the user, just like we use ask block. And so these semicolons are referred to, we are creating a void. Void is nothing but a space for separate function. So whenever we are using this loops or conditional statements, we just use this flower brackets to indicate that we are giving a space, a separate void for them to process. So the result 1 is equals to input 1 and input. So we are creating a square of the number first, right? So input 1 into input 1, and then return to the result, so which is print statement. And for the cube of a number, we are creating cube of a number function, and we are taking the input 2 from the user. Result 2 equals to input 2 into input 2 into input 2, like 3 times. So it is, which is cube of a number, so return result 2. And in the main function, so this is functions void, and this is main void main function. So value 1 equals to square of a number, value 2 is equal to cube of a number, so here you have to change it to cube of a number, and value 3 is value 1 plus value 2. So we are adding square and cube of a number. So this is how we write a pseudocode for any other programs we have. And then let's move on to the next topic. So next topic is understanding collections. So first, what are collections? So collections, okay, a collection is nothing but a container that groups multiple items into a single object. So collections are used to store the data. We can also retrieve and manipulate the data that is stored in the collections. For suppose it is just like for suppose in an example we can take, it's a collection of voters in particular area. So that is a data, right? So this data with individuals all will put into one container, which can be referred as an Excel sheet or a logbook that we have. So this all data is called a collection. This collection can be used, can be retrieved or manipulated. So these collections are not like once you have entered the data, you can't change it or you can't manipulate the data again. So it can be retrieved. Retrieving means like we can take out the data and use it in the code, or you can manipulate the data that's stored in the collection. And the advantages of using collections. So here collections allow programmers to group, now it is visible. Yeah, Collections allow programmers to group multiple items into a common set. So grouping of items make it easier to identify and perform different operations on them, like retrieving and modifying data. It increases the performance of the program, and it increases the productivity and reduces the operational time. So our whole point of doing the programs and this thing is like we need to increase the performance, increase the efficiency, reducing the code time. So, and it should be more operational, like very fast. So every other technology that we are getting is like we used to have telephones where the communication used to we used to do with the wired communication, and making it a little better, we used wireless communication, which is like radio, which is from radio frequencies and everything. Now we have modulated waves, which is in the phone calls we can just connect to LTE waves. And then now we have internet, 4G, 5G. So this all technologies will help the mankind to grow more and more. So utilizing the time, utilizing every minute of the life is most important. So that's why we are, even in the program, we are trying to write the program in such a way that it will be operational, efficient, and less time consuming. So even if we are explaining the program to someone else also, it should be easy to understand. So that's why we have to learn all these techniques that we have. And let's see collections work in PictoBlocks. So in PictoBlocks we have make a list in variables under the variables. So you know where the variables. So here there is a make a list block is there. So we have the collections can be implemented with this list. The list is available in the variables palette, which is there. So now we are moving on to one activity, building a zoo. So in this project we are going to create a zoo in PictoBlocks. So yeah, first we have to add the collection of data. So here the collection of data is something like animals. So something like bear, bat, crab, lion. So these all blocks are added to the list. Delete all of animals. First we have to put this and then this one. And ask how many animals do you want. If you put that answer, and create a clone of animal, myself for animal. So let's see. And next, if we are creating the clone, when I start as a clone, show switch costume. So item have to pick a random 1 to 4 of animals. So how many inputs that we have given, go to random position, forever glide for 3 seconds. So let's see. So I'm gonna delete this program. So now this is not in use, even the radius. So first we are making a list here. This name is animal, or you can, it is zoo, whatever the name. For all the sprites we are creating. And now we are, so here you can have this pop-up of variables. So these are all the variables that we're gonna use in this particular set of program. So now we'll go to events when flag is clicked. So first we have to make sure the list is empty. So that's why we are taking delete all the animals here. So this is the block, and add 1, 2, 3, 4, 5. So we might need, initially I'm taking 4 add blocks. So here we have to add multiple horse, bear, so it's bat and crab. So we have ordered, so even you can put lion here. So these are all the things. Okay, we have to make sure this in capital because it might take an input. It's a noun, right? Okay. Lion, bear, crab, bat. Now ask how many animals do you want and have to wait. And in a repeat block, we have to add that answer and create a clone of animal. Go to control, sensing, ask and wait, repeat, create a clone of myself. I have to take the answer, put it in the how many times we have to repeat the block. I have to change myself to animals. Once again, there is no maybe we have to take animal. Yeah, first we have to take animals. So now it might have clone of Toby. Okay, there are okay, let's see. I'll just do create a clone of myself here, and then when I start as a clone, show switch costume to item to pick random of animals and go to the random position. So let's see, when I start as a clone, show switch costume to item. Item will be available in this. So switch costume. Variables I might find items, random 1 to 4. So we need a pick random 1 to 4 because our length of the list is 4, right? And go to random position. Go to random position within the stage and forever glide for 3 seconds and pick random position. We'll just increase. Okay, and here we have to enter not what's your name, but we have to put how many animals do you want. I have to ask how many animals do you want and wait. Now run the program. So just put 3. So 3 Tobis will be created. They're just taking one random position. So if you take another sprite of animals or bear or something, so it's just gliding here and there in the arena. So this is how we create a list, and we can, from the list we can choose the data, and we are taking the length of the list. So list and collections are same. So in other programming languages, this collections are called lists. So just for your reference, just letting you know. So we'll just have a break of 5 minutes, and then we can start next understanding arrays part. So if you have any doubts so far in this last 2 activities, please let me know. I'll just open the chatbot. Yeah, here it is. Okay, it's too fast. I'm sorry. I'll go a little slower. So Saida, can you please repeat like which part didn't you didn't understand? I'll just repeat the part. So I didn't see the text. It was at 5 minutes before. Okay, it's too fast. Okay, I'll try to reduce the speed of the lectures. So if you are copying this program, just please do it. We're gonna have a break of 5 minutes, and we'll just get back. I'm back, guys. So JavaScript is telling that, okay, I just even I figured out that it is just creating a clone of the same sprite. Not understand, the list is cloning one sprite, yes, and the animals thing, actually it has to create these animals and has to take one from each sprite. So we have all the animals, right? So here some animals are missing. So we have a polar bear, and it might be the software issue, or so the crab. So we have bat, bear. Yeah, we have to create different costumes in one sprite. Yeah, even that will work, but it will take so we are programming for only one sprite, right? So maybe if we do the program for the stage, it might work. You guys please try it once, the same program in the stage, not on single sprite. And these, I guess there is one more error. So I can't see the lion, even the horse is there. Okay, see here. So I'll rectify the error in the program and I'll get back to you. So in the last 15 minutes we can discuss this thing. Yeah, we have to create different costumes in one sprite. Yes, maybe that will work. So I'm sorry, this is mistake from my side. I just made the program in one sprite, which is Toby. So we have to do this program in the stage, so without any selecting any sprites. But we have to select these multiple sprites here so that it will change. So have to go to animals, one bear, bat, crab, one more bat. So this, see, we have crab and a lion. Yeah, lion. Yeah, these are the 4 sprites we're gonna use, and then we have to do this same Toby's program into the stage. Then I guess we can create the multiple clones. Let's say 3, then 3 less will come. So this is not the actual output. The output is we have to get these animals in the background. So I'll just rectify the program and get back to you. For now, we'll go to the next topic, which is understanding the arrays. Javishek, thank you so much for rectifying the error. I'm happy that we are being interactive in these classes. So I'll rectify the code. So yeah, next topic is understanding arrays. So what are arrays? So an array is a collection of similar data type variable. So it is, array does not support different data type in the same collection. For example, you can make an array of integers as well as another array of strings. However, you cannot make an array having integer and the strings in the same collection. So we have some limitations of array. Array is to improve the readability of code by using a single variable for a larger set of data. However, there are the following limitations that we need to note while using arrays. So while using arrays, you can only store variables with the same data type in one array. So if we are taking one collection of numbers, we can just add those type of data only in one array. So the variables in an array are always ordered sequentially with the index starting with 0. So the variables in an array, if you want to label them, so they will start from 0. So like 0, 1, 2, 3, the list of one. And collections in PictoBlocks, we are just continuing the same topic. But array is also a set of data array. So collections in PictoBlocks, we can take from make a list. So adding elements to the array. Now this is the project. In this project we want to do the following. So when the script is start, the command C button is pressed. On start as a user, the maximum values in the elements. Okay, I can. Okay, switch off. On start as a user, the maximum value of the elements allowed in the array. Then ask the user how many elements should be there in an array. Based on the above inputs, create an array of specified length with each element valued picked randomly between 1 to the specified maximum value. Just go through this again. Yeah. Now when C is pressed, C key means like a command start. So we have to ask to enter the maximum allowed values of the number in the array, and we have to wait. We have to take that answer. So that is our range, a range of our the following list or following array. So and then we are so this delete all array block is to make sure there is nothing assigned in to the particular list, particular array. So delete all of array and then ask, enter the number of elements you want in the array and wait, and we have to repeat how many times that, how many elements that we have to display in the order. So repeat, ask and take the answer, add pick random number 1 to the total number of maximum number of values that we are taking from the range, and we are assigning that value to the array. So yeah, let's check. Now I'm taking a new file. So we are creating a list called array here, and when C key is pressed, when some other key, space, okay, I'll just put C, sensing, ask what's your name, then set range to an answer. So or you can go to, so have to set range. Okay, we have to create one array called range also, I guess. Yeah, okay. We have to create one variable of range, and this has number type. So set range to the answer, sensing answer, and here we have to type the maximum allowed value of the number in array. Set my variable to answer. Yes, that's what. So now we have to set the range to the answer. So this is range. So delete all of the array, delete all of the list, and ask the enter number of enter number of elements you want in the array. And then we have to repeat the answer how many times we have. So it will take the second iterated answer. So in the first block, this answer will go to set range of it, and then the second answer we take. So we have to take a pick random one to the range, and it will take add it to the array. So we'll take repeat answer, repeat until my answer, and then we have to add in the block. So add thing to block. So I have to pick random one to the range. In the variables we have our variables range. So now let's we have to press C, enter the maximum value of array. So I'll just take 10 values. I want 9 elements to be added. So these are the random list that we have created. Now let's try it again. I want so I'm taking here an example of the number of students that can fit in one room. So I'll just take the maximum number to 30, and then so the random numbers from, so if I want to put, so the total number of people that can be fit in the room are 50, and just for now I'm just 30, and I'm just taking to 25 people to allowing 25 people of some random. So it will generate 25 random outcomes from 1 to 30 without repetition. So for suppose these are roll numbers of the students, so it's like 4, 17, 9. So these roll numbers can be fit in this room, or it's just like a creating a this program is like creating a random group of students within themselves without repetition. So if they want to do a lab activity or something, we can use this kind of program to generate a random. So yeah, this is one activity on arrays. I guess you guys got this, understood the arrays. So next activity is on operations of array. So in this activity we want the program, the output, the first element of, we want the output like the first element of array. When the F key is pressed, it should print. So when the S key is pressed, set the count to 1, set the sum to 0, and repeat the length of array. Change sum by the items in the count that where we took the input from. I have set the value to 1 of array, and then change the count by 1. So it is increment block. And then at the last say the sum of, if the total, the length of array is closed, then the sum should be equals to sum is the answer, and then close. So let's try it. I'm removing this. So we have one statement of array here, and now we are creating one more variable called count and one more sum. Let's create SCOUN count, and it's a number type for all sprites. Again we are taking sum number type for all sprites. We are not using range, so we can delete that one. So let's start with when some key S is pressed or F is pressed, whatever the key you want to add, it's everything is same. Set count, go to variables, set count to 0, set sum to 0, count to 1. So we are starting from 1 and repeat the length of array. So we are go to events, control, repeat the length of array. You can find it in the variables. I'm just checking the color of it, so where to find. So you can use this like a tip. So whatever the block you want, you just can search it according to the color. So I am doing, so my repeat is length of an array, and then change the sum item to the item that we are taking from the count. So this is a little important one. Change the sum. Item and we have to take one count, item count of array. So the sum is changed by the item count, number of items that we are taking. So initially it is number 1, and then change the count by 1. So this is increment block. So even the sum is increment, but we are taking the number of items to be stored in an array, and we have to say sum. So go to looks, sum is equals to sum. Now let's run the program. So as key is pressed, so it's taking one random, okay, it's taking the number of the count that we have given already here. So just it is taking the elements from this list. We are just not taking, so it's already, so we have to empty, delete all of array. Yeah, so we have to add this. Sum is 0. And here we can add the input say block. So in sensing, So if I give input of 43, it will store in the sum of and we are saying sum of count by the items, number of items in the array. So we have to take length of array. Yeah. So this is how we take, if we take the count initial value as 2 and we can add the items number to the array like this. The count value is just returned in two iterations. So and the total number of this elements are 1 and the sum of the things that we have entered here, it's entering to the sum because we put this block change sum by item count of an array. So yeah, then we can have, there is a fun activity, my friends list. So if anyone wants to copy the program, you can just copy. We can just take 2 minutes for copying the program if anyone is doing. So I'll just increase the size. So we'll look into some of the chat box now. So Preeti Raut is asking that is PictoBlocks is also known as Scratch. So actually Scratch is a software which uses the block coding. We can say PictoBlocks and Scratch are similar, but Scratch doesn't have these extensions that so the difference between Scratch and PictoBlocks is the programming, the part, everything is same, but these have some AI extensions. So we can say just like one package of all this face detection, object detection, human body detection, so recognition cards. So here in the programming, initially so we use the same concepts as Scratch, but when we are doing the AI projects, just like, so we created the curriculum like it should be interactive with the audience every time. So even the planner, so if there is one serious topic like theory and everything, so there will be one fun activity and also hands-on which where the audience are feel included in the topic, so whatever they learn. So yeah, and the Scratch is just to make animations, to the similar kind of programs also we can do in the Scratch, but this extensions we can't find in them, and we can't integrate Scratch programming with the robots. So I told you, right, we're going to use a microcontroller chip for dumping the program, so this can dump. Yeah, and then one more. Good morning. Jarvan said go slowly, so I'm trying my level best to go slower. If it's an offline session, we have much more interaction between us, so you just tell me where can I go slow, how, while doing the program or while doing the explanation, or where. please let me know. I'll just rectify it from my side. Okay, yeah. We'll go to another topic. The topic, this is called making my friends list, and the iterations over the collections is the main topic here. So the iterations are used to provide users with an uniform way of accessing the collections in a sequential manner. So a sequential manner means like if you have a list and we have to put the list in a sequence, not picking up a random. Just like when A is pressed, first we have to add a friend to the list. When L is pressed, find the numbers of friends. When F is pressed, finding whether sometimes if your friend is not there, so if they are present or not. So just like creating a community program, friend community program. So when D is pressed, delete a friend. When C is pressed, delete all my friends. So we are putting one for each number, we are assigning one letter here. So this is how we'll, so when the C is pressed, it deletes all the friends in the array. So let's start doing it. So first, adding the friends to the list. So we'll just you can take any other keys of you like, but you have to make sure you remember whatever the keys you are taking. So I'm just taking a new file from block coding. When A is pressed, ask what is your friend's name and wait. And this is for input, adding friends in the array. So when A means add, so A indicates add, right? So I'll put A, key pressed, ask the friend's name and wait. Sensing, or just put add name. And answer will take it later. And then we'll take one if else block. In that if else block, we have to take a variable, like we have to create a list called friends which contains the answer. If it contains the answer, then say join answer is already added for 2 seconds. Create the list name as friend first. Make a list. FRIEND. Yes. So here the list is created. Now we have to take one if else block. Guys, I'm audible now. Okay. Friends contains the answer. Then we need to add join. Say join answer is already added for 2 seconds. Else we have to add the number list to the name to the friends list. So it matches the variable that we have added if the name is already there in the list. is already added for 2 seconds. Else we have to add a thing to list, which is the answer, and say done for 2 seconds. We'll take, say, I have new friend added for 2 seconds. So this is one block. So I'm just scrolling it. If you want to go a little slower and like type the program, do the program parallelly, you can just pause there. You can just take a pause of the video and you can do this program. Now second program, finding the number of friends. So finding the number of friends, we just take when one I key is pressed. So I'll take I, say join, you have the length of friends. So how many friends are there? So it will just tell us. To events, when I key is pressed, it will say for 2 seconds, and then it will take join, you have the length of it. So we'll take operations, 2 join blocks, this you have length of friends. So the length of the list, yeah, then now we have to take one other key, which is F, and put on only this I'm so sorry, I didn't switch on the first mic. Yeah, I'm so sorry. So this is anyway we're gonna do the same program for tomorrow. There is a few more continuation is there. We have to add two more keys here to delete. So as the time goes, the mic will switch off. So it's not an issue. I'm sorry. I'm sorry. Thank you for your responses, guys. I don't know that you're here on the audio. Yeah, I guess today's session was a little interactive. Thank you so much. And I'll for Javed, I guess I'll get back to you with the answer of the animal activity, right? And anyway, we're gonna discuss the same program tomorrow also. We just have to add two more blocks and then we can continue to the next topic. Okay, so if you have doubts so far, please note them down. We can have it tomorrow. And still, okay, we're gonna take a break for next 15 minutes, and the next session, maybe next session will start in 10:35 or 10:45. So thank you so much for your time, guys. Have a good day. I'm gonna take a leave.
Good morning, everybody. I hope I'm audible. Please let me know. Please let me know if I'm audible so that I can start with the session. Once we will complete this 12th session, we'll have a recap of all the sessions which we had, and I will try to give you the assignments so far. Yeah, now it's clear. Sorry. Assignments in related to the topics till whatever we have completed so far. I request you all to please put up any message if I'm audible or not. Yes, great. I got a message. Yeah. So now that I'm audible, I hope you all are with me. Everybody's back from the break or so. We will start our new topic. The first thing is, the 12th session, that is Introduction to Smart Contracts. So this is one more very important topic in blockchain. So far we understood what is a blockchain, how it works, and etc. etc. But then this is like a addition which you can add into blockchain technology in order to make it more efficient and a better way. So before that, let's do one thing. We will learn whatever we have learned so far. We'll just recap everything so that you can understand this in a lot better way. Because smart contracts requires a brushing up of little. One second. Yeah. Good morning. Yeah. So we'll just have a small session about it, and we'll continue. So yeah, this whoever missed the few classes, also please try to concentrate here so that it'll be great for you and us, at the same time that we brush up everything again, right? Great. So yeah. So first thing, we learned what was the first session, that is Introduction to Technology and Digital Transactions. So while we were discussing about technology, we can say it as overcoming the traditional methods and coming up with new, innovative or a better ways in order to solve one single thing. So that is the best example we can give for technology, because with technology we kind of make things even more faster than before. We kind of make things easy than before. And digital transaction is nothing but paying with digital money and not the hard cash, right? Thing which you do through digitally, that is to your phone or something like that. Those are nothing but the digital transactions. So first of all, let's understand what is technology. I know this is all a repetition, so I'll take it super fast or so. But then I want you all to, please be interactive as well when we start with the next session. And if you have any doubts in between with these type of sessions, the things which are already done, please do not hesitate. Please try to put up those messages and we can discuss them. And this is the best opportunity because I've been repeating everything. Now, once we repeat everything, you might remember the doubts which you have or so. So yeah. What is technology? Technology is like a superpower that makes incredible things happen in our world. It includes gadgets like computers, phones, and the internet. These tools are everywhere and make life easier and more exciting. So talking about this, we can say that in olden days we had phones which were only connected through wires. So if you have to talk something, it's only about wire. But now your smartphone is one live big example. And internet. Before, let's say if I have to teach the same thing, I'll have to come in front of you and do that. But now I can do it online. So the evolution that I can say is technology. The better way which we found out in order to, work it better, get a nice solution. That any innovative thing is called technology in that aspect. So now, as we were talking about technology and digital transaction, what is a digital transaction? We just told that it's UPI, you use your phone or so, but what is it? Technology is digital transaction is nothing but paying through your phone. So I hope you all remember this video which we had before about how blockchain works. I request you all to put up a message if you think we should play the video again or it's not required. Please put up a message. Meanwhile, I'll just read those 2 points which we learned about blockchain there. Blockchain is like a super secure digital ledger. That is, every transaction is noted down in a way where it's line wise. It keeps track of all digital transactions, and each block stores a lot of transactions. So in one single block, I can say there are another million blocks. Like every transaction is noted because there are millions of transactions happening like around the world while we speak as well. So all these being noted down in block and block and block and block. That's how blockchain works as well. I request you all to put up a message if you think I need to play the video again. If not, I will move further. That's why. If you want it, I'll play it again because or I can repeat what was there in the video. So just need 1 or 2 text stating whatever you want. I'll wait for a minute. Please let me know. This story was about Jacob and how blockchain works. Okay, I'll do one thing. I'll just play it up because I am not getting any response. Yeah, I will play it for y'all. Please let me know if it's at least audible or not. Just give me a second. Please skip video. Okay, great. So then let's not go for the video part. I'll just repeat what is there in the video. Just explain, please. Okay, sure. So yeah, while we were learning about this blockchain part, when we saw this video, it was a story about Jacob where he wanted to send what gifts he wants for Christmas to Santa Claus, right? So in that, it was like, how do I tell you? He wanted a blue cat, okay? So when he wrote a letter to Santa and he asked his dad is nothing but the middleman here. He wanted the middleman to post this to Santa. But then his dad saw what was there in the message and he changed it to a pair of socks. That was in the video. So due to this middleman, he couldn't send his message to Santa Claus directly, and nobody knew who changed it also. I mean, like Jacob doesn't even know that his father has changed it or not, right? So what did Jacob do? He came up with this. He understood what is blockchain. He connected to the blockchain of the North Pole, that is the Santa's place. In that blockchain, he posted what he wanted for Christmas. And in the same blockchain, his dad was also present. So when his dad was also present in that, he saw that Jacob has posted a message regarding that he needed a blue cat. So when he did that, the dad, being again like trying to being the middleman, he changed the message. But in blockchain, we all know that all the systems, all the servers are connected, and once you make a transaction, everybody will have a copy of it. So in later classes, we learned about the hash function and like the unique number or ID which is generated also. So let's say whatever Jacob has put up in that, nobody knew what was in it, but everybody knew that there was a transaction that happened and everybody had a number. So in the classes, we also learned that the hexacodes or the hash functions are generated using the message, like whatever is in there. Yes. So let's say the dad tried to change the message. So of course the unique ID is also going to change. So as everybody has the copy of what Jacob has sent to Santa, when his dad tried to change it, it was very easy for them to identify it. So his dad was removed from the blockchain and his message went to Santa Claus. So here the point is, as everybody can see whatever transaction or thing you have made, nobody can try to change. It's immutable. So here it's about basic example about how you can teach your students as well in the same way. So that was blockchain. It's nothing but a digital ledger which will record all the digital transactions. So let's see how it works. Blockchain links blocks of transactions together like a chain. So yeah, as we were speaking, in one block there may be 100 other blocks, and this block is connected to another 100 blocks which are there. That is another 100 transactions, we can call it as. And every block in the block has special code. The name is called hash. So who will check these transactions? The miners. Let's say when we were discussing about the Bitcoin mining or so, right? So we heard that like the computer needs to solve super complex problems in order to generate one like the unique ID which we can't find anybody anywhere else, and your Bitcoin is mined. So just like that, if the miners want to develop a thing which is unique, first they need to check what are already there in order to come up with a new one, right? So if there is a transaction and somebody tried to duplicate it, the miners, it's very easy for them to identify because they're two things with the same unique ID. So that means somebody is trying to replicate it or duplicate it, right? So that is how blockchain ensures security. And yeah, talking about digital transactions on blockchain. So blockchain makes digital transactions super secure because everybody will know what is a transaction, but nobody will know your data, like your name or your timestamp or to whom you have sent, etc., etc. It's like having a super smart friend who checks everything. Of course, once your transaction is made, it's immutable, you cannot change it, and even if somebody is trying to change it, you'll identify it immediately. So it's like a smart friend who checks everything, right? Blockchain is so transparent, which means everyone can see the transactions. Again, everybody can see the transactions but not the data, that is your name or the credentials, your UPI ID, or so that nobody can see. They can see that you made a transaction, they won't even know what is the amount of transaction you have made. So these are the three important benefits of blockchain. If you haven't made a note of it, I request you all to please make a note of it, so that when you want to answer certain set of assignments and all, it will be helpful for you all, right? So here, benefits of blockchain. First thing is security. We all know transactions, it is like a super secure and safe to use. And transparency, as everybody can see what is happening. It's super, you can rely on it, right? And decentralization. This we are going to discuss, even in a deep way, as you all already have seen the sessions. So we will continue with that because we have a better version of decentralization where you can note it down, right? So yeah, let's go to the next session and we'll recap super fast so that we can complete. Yeah. Yeah. So the next one was understanding the need of secure transactions. First of all, why do you think we need secure transaction? I want you all to put that up in the chat box. I'll wait for a minute. What is it? Why do we even need? What happens if your data is sent out? What if everybody can see your data? What is the problem? Please put up your answers in the chat box. I will wait for a minute. Please let me know. One answer at least I expect. I want to keep this interactive. Why do we need a secure transaction? Why is it important to save your data? One answer at least. I'll be waiting. Please at least put up one answer. Why do we need secure transaction? We can make it interesting only if we are interactive and we talk about it. We discuss about whatever is going in the class, and whatever doubts you have, please don't hesitate. I request you all to please put up at least one message. Meanwhile, I will continue, but I want at least one message. Yeah. So from fraud, yes, perfect. So it helps you from fraud. Let's say I have a identity and all my data is released, let's say my name, my date of birth or so. It's very easy for other person to take all this data and keep it exactly like their own identity. Maybe they can do that, right? And they can get people from somebody else as well. Yes. So that is how it happens. So and maybe giving out your identity can be sold to these marketing people, to market their own products according to your personality or so. We have seen many things, like even these days, let's say I talk about something, you see similar type of things in either like Instagram or so the moment you talk about it. So how is that happening? How is this marketing happening? Is your data actually going out? And that's the reason we need to have a secure transaction or security for your data. So here, when we talk about this, but as we all know, we need it to be secure and it should be safe. How blockchain is going to help? So when we talk about this, blockchain uses special technology to keep the transaction safe. So it's a new blockchain is already a new technology, right? But then the things involved in it in order to make it secure, that is what we are going to learn in deep as well in all the upcoming sessions, and even in the 12th session about smart contracts, which we will be discussing. And yeah, every transaction is verified and verified. What is the meaning of verified here? Verified is nothing but it's like if it's unique or not. Is it being repeated? Is it being replicated, or is it being duplicated? Right? So the moment you make a transaction, they're going to the miners will check if it's like it's unique or is it original or not, and once if it's verified, it is stored in a block, otherwise it's immediately alerted. Once a block is added to the chain, it's very hard to change it. We are talking about immutability here, that once added it can never be changed. So this makes blockchain secure. So these are the 4 things which we'll discuss like in detail again, that is encryption, transparency, decentralization and trust. So starting with encryption, it's like a secret code. So like whatever message or whatever data, whatever transaction you will be making, out of that data there is going to be a unique ID which is produced, and this is encrypted. Of course, nobody can decode the message. No outsider can decode the message with in order to get the data. Only the receiver and the sender we will be able to encrypt it. So here encryption is like, let's say you send from some Instagram account and it's your login credentials, and when the other person receives it, he will be able to see only if he has the password to his own account. So it's like you're sending your message, right, and no outsider can log in to see your messages. It's like only the receiver and sender can refer to it. So this ensures your transactions are private and secure, protecting your information from unauthorized access. So this is encryption. If you wanna make a note, I request you all to please make a note. I'll just try to put it clear. Yeah. So I request you all to please make a note of these things so that you will need these definitions later on. So please put up, please make a note. I'll go to the next one. That is decentralization. This is the better, version of the definition. It's better you note down this one. I request you all to please make a note of all this. You might need these definitions later on. I'm going to the next one. I hope you all noted it down. The next one is transparency. These are the bigger definitions and you might need it. Once these definitions are done, we'll move fast again and we'll start off with the next session also. But I request you all to please make a note of this. Yeah, so I hope you all noted it down, and this is the last one. Trust is nothing but here we have a word called peer-to-peer transaction. And the other day we also had this concept like peer-to-peer network. So while I continue the class, I want at least one person to put up a message of the difference between peer-to-peer transaction and peer-to-peer network. So what did you understand from it? And I request you to please put it, I expect at least 5 answers for this question before we end the session. I repeat, please put up the difference. The question is, what is the difference between peer-to-peer transaction and peer-to-peer network? There is a difference, and a lot difference actually. I want you all to put up that message. I'll meanwhile continue because I don't want to waste time as well. But I want at least 5 messages, and I will reciprocate for the same. We will discuss if they're right and how it is different. Okay, but I need at least one person, or 5 people to work on it. So session 2 is done, and now we are just recapping everything we have done so far, so that you'll have a better idea about the smart contracts. I'll go fast from here. I just don't want to waste a lot of time because smart contracts is a little big one, but we need to have the recap in order to understand how smart contracts are efficient. So coming to this, we already know what is a blockchain. Here, its key feature is like digital chain of blocks that cannot be changed once they are added. This is a very key feature, that is nothing but the immutability part. So coming to this point, it's like a puzzle. So everything has its own unique shape. Once you fix it, nobody can alter it. Right? You cannot remove it back, you cannot change it back, you cannot make the same thing again, because its place in a big puzzle, its place is already set. So once the block is full, it's sealed, connected to the previous block, forming a chain, let's say a box. And I hope I can say that, right? So let's go to the next one. Yeah. So coming to the next point, that is decentralization. We already had a very good definition about the same thing, right? 1 second. Yeah, we also had a definition about this. Decentralization, nothing but there is no single boss, there is no person who is going to control all this. If you want to do if you want to make up a decision where everybody needs to agree for the same, right? And that's how it's going to work. I request again, I want at least one answer about peer-to-peer transaction and peer-to-peer network. I will keep repeating until you give me at least few answers. The next one, for decentralization part, for the teachers, this is the best thing, to make them understand the concept. Come up with the activity, divide them into groups and ask them to build tower of blocks together. Maybe you can use some erasers or so. So when you do that, if they all work together, then only the tower is going to withstand, otherwise it will simply break. So we can tell them that here teamwork will work, where everybody needs to agree to put up one block on the other, and what shape or what size they should be choosing and all, right? And transparency we already had. This is one more new concept, that is immutability. Once I got a message, 2 or more computer system to connect and share resource without requiring a separate server. This is the answer for peer-to-peer network, right? This is a peer-to-peer network. But what is a peer-to-peer transaction? Yes, this is for a peer-to-peer network. That's the right answer. 2 or more computer systems to connect and share resource without requiring a separate server. This is the answer for peer-to-peer network. See here, let me tell you the difference by myself. That is, in peer-to-peer network, you can share from one computer to other or so. In peer-to-peer transaction, everybody will know what the transaction is made also. Let's say this is a private blockchain. In peer-to-peer transaction, everybody will also know what is in the transaction, that is all the data as well. But peer-to-peer transaction means 2 person are buying and another person is selling. I didn't get your point, I'm so sorry, and I don't think that is a right answer as well. We are talking about in blockchains, okay? So peer-to-peer transaction means person A to person D has sent certain amount of data. and where everybody in the thing will be knowing about it. So transaction is nothing but it can be amount or data. In peer-to-peer network, let's say there are a group of people, traffic pullers, who are there. So if I talk something, everybody will listen to it and everybody has a say in it. It's about sharing some information where everybody is aware of and everybody will give their own point of views. And again, decentralization and this differences, in decentralized system everybody needs to agree on a point. In peer-to-peer network, everybody comes up with a point and it doesn't have to be agreeable. It's just about like a discussion. Where peer-to-peer transaction is nothing but person A to person D sending some data and everybody in that peer group knowing about it. So I hope you got the answer and I hope it's like clear enough. So again, coming back to the concept of immutability, once a data is recorded on a blockchain, it cannot be altered, deleted, changed or whatever. So here we can say all the synonyms for change can be used for the concept of immutability, right? So once added, it cannot be changed. This is one more concept. But then because the immutability gives a certain set of things, that is data integrity. That means your data is like the high quality one, that it cannot be altered, even replicated a little bit. So it ensures giving us data integrity. It increases trust because your data is safe, and once if anybody even tries to steal, change or whatever, it's not possible. So this immutability concept is suitable for tamper proof records. The best example of these tamper proof records is nothing but your own ID cards, government ID cards. So those things cannot be tampered. They should not be changed no matter what, right? So that we can say the immutability concept works there. So the next one is security. It use special code, that is that nothing but the unique ID which we develop in order to put it safe. So yeah, this also will skip. These are the use cases. Like we all want to know, why do we even use blockchain technology? Yesterday also for the case studies we have discussed few. So cryptocurrencies like Bitcoin. Of course, Bitcoin is one big example where blockchain technology is used the most, right? And digital collectibles like NFTs, non-fungible tokens. As I asked, I want you all to come up with one use case that has already been used, right? So next, tracking food items. Tracking toys. Yesterday we had a case study where how this blockchain technology can be implemented there. So the challenges, simplified explanation of scale. So as everything has its own good or bad, when we talk about this, scalability. So as many people want to keep it private, right? Will they even be okay to come up with this, they won't be involved in this blockchain. They would not be encouraged to come into blockchain as they don't want to be transparent. So it's not very scalable. It's not like it's in demand and everybody will join or use blockchain technologies. The second one, interoperability. Let's say there's a blockchain of around 1 million people. Can the second person talk or identify the person who is maybe in the number of 99, 999 or so, right? So we can say that is not possible, humanly possible. Yes. And the thing is regulatory issues. Let's say we spoke about miners, right? When we spoke about these miners or so, what can we say, we spoke that they will be verifying the transactions if it's duplicated, replicated or so. But then it's miner's choice when to do that. So it cannot be regular, it cannot be monitored regularly. So this is one more issue with blockchain. If we have somebody who can actually do that, then that's a challenge which you can face. The next one, energy consumption. So as we were talking, each Bitcoin takes days to mine, and it takes a lot of energy, and it also takes a lot of solving part. So that is also one more challenge which we are going to face. And the last thing is emphasizing. You can't say one particular person to do something, right? You can't say one particular person to complete their part in that blockchain. right? It's not like this is one more big challenge. So yeah, let's go to the next one. One second. Yeah, this is session 3, so we'll be in 4. Or I just want you all, okay, should I start off with the next session, or should I do the recap part? I request you all to please let me know. Just give me, like, I'll take a minute, please tell me. To a network or system which participates communicate and share resource directly with each other without relying on a central system. Yeah, that's correct. It's about a network. True. I want you all to tell, should I continue the recap part, or like what do we do? Okay, anyways, I'll continue then, because I'm not getting any answers. I'll go super fast so that we can complete the smart contracts part before time as well. So coming to this, understanding blocks in blockchain. So blocks are nothing but basic units of data storage, like whatever transaction is being made, it is data storage. Please continue with recap. Great, thank you so much. So they contain information about transactions along with important data. What is this important data? Again, it's nothing but your name, timestamp, the receiver's name, what is the amount, or what is the data you have shared, what is the storage level of it, or so. So all these together refer to one single block. And now we will talk about structure of a block. There are three things: header, transaction, hash. Header is nothing but it is the metadata about the block, such as like version, which version are we using, timestamp, and the reference to the previous block. That is nothing but the hash pointer. Great. So that thing can be referred to as hash pointer. And transactions, these are the actual data stored within the block representing actions or exchange of value. So of course, as we were talking, transaction is nothing but the actual data about the receiver's name, about the sender's name, or about all these. And then hash is nothing but the unique identifier which is given to every single block. So we call it as cryptographic hash, as it is like a combination of many algorithms together in order to produce one unique number using the data which we have, right? And then then there are 3 components, that is header, transaction, hash. I request you all to just make a note of it. I won't take much time. We will start off with the next topic also, so that you are also not bored. But please make a note again, because these are little important things. Then, how are these transactions actually connected to blocks also? Transactions are nothing but exchange of digital assets or data. Transaction doesn't have to be just related to money. It can be anything you send from here to that person, from your end to the other person. So it can be a digital asset. Digital asset can be told as this cryptocurrency. That is the perfect example to tell it is a digital asset. So like sending cryptocurrency or recording ownership. So let's say you're selling a land or so. So you need to have details of yours and also the person who is buying it from you, right? All these together will make one block, and all these have the data about the transaction. And these transactions represent action within a blockchain network, such as sending cryptocurrency, as I was speaking. That is nothing but a Bitcoin, for example, recording ownership, or executing smart contracts. So here also we got a thing called smart contracts. Now we are going to discuss that in our regular sessions as well. So including transactions in blockchain. Blockchain contains multiple transactions grouped together, forming a okay, so let's shorten it down. It is nothing but a single chain, right? It's connected linearly and also in series. So when we talk about structure of the blockchain, that is the first thing your answer should be. So chain structure, here it is there. It is nothing but interconnected blocks in a series, and it is linear sequence. So these two words are a little important and like main thing in blockchains. And why should we even link them? Linking blocks ensures the integrity and immutability of the blockchain. If any, let's say if any alteration is done to the previous block or so, the whole chain will get disturbed. So you can't even make it. So it will ensure immutability no matter what. So this is one more. And talking about how chains are formed, the first block is called Genesis block, and all the other blocks are added to the Genesis block. The Genesis block will not have the data about all the other blocks which are going on. Got it? Yeah. So this is about the fourth session. Now the fifth session was about your activity, where you had to divide up the students among yourselves. Like one will be the person who's sharing the data, the other person will be the the other person will be the person who is going to verify all of that, and if they all achieved consensus mechanism. Again, speaking of which, consensus mechanism is nothing but everybody agreeing to one single point and everybody accepting it. So I hope you remember the activity, because we took almost a lot of time in explaining that. Now we'll continue with this. We understood what is a Bitcoin in this session. Cryptography is nothing but like a secret code which keeps our messages safe when we send them over the internet. So it's like a encoded version of your messages. So there are three concepts, that is encryption, de-encryption, and key generation. Encryption is nothing but turning a message into secret code. Encryption is nothing but turning it back to the original message, and key generation is making a password or a lock in order to keep your message safe. So here there are two types. One is symmetric and asymmetric. Symmetric is the same, like it's the same key for locking and unlocking, but asymmetric has two different keys for unlocking and locking. So examples and all you already know, and hash function we already spoke about the algorithms, and I am so sure you already got this assignment where you had to write about at least two algorithms, right? So let's now come back to this session, as the next one was case study. We'll go back once we complete the smart contracts part. So yeah, introduction to smart contracts. What are smart contracts in general? Let's not talk about in terms of coding or software or blockchain. What is the meaning of a contract, first of all? Can we say contract is nothing but an agreement between two parties, right? And what is this smart before it? So what does that mean? True smart people? Let's see. So definition of smart contracts. Smart contracts are self-executing contracts with the terms of agreement directly written into code. So see, there are two answers that people might be giving. One is maybe whatever contract you wrote in the form of message is converted in the form of code, like ciphertext, like we were discussing about cryptography, right? Is it that, or it's a different one? People from CSE background might know it way better. Please answer that question. Is it this, like whatever you have is directly being converted, or is it something like it's different? Now let's start discussing about what are smart contracts. Smart contracts are digital agreements that automatically execute and enforce in the terms of contract when predefined conditions are met. So here, smart contracts are nothing but which work on if and else statements. If this is done, then this will happen. So example here in the vending machine is, when you insert money, it should dispense whatever you select, right? So if the money is given, then. So if and then statements are going to be used in all the smart contracts, and we will discuss even better way about these. So here, so let's say I'll take an example. Let's say a client has come up to me. He's asking some certain site, like create a website for me, and in that you should, once the website open, it should let's say it should say a welcome message to the user first, and then it should show the items in the website. Let's say he's doing some business. So here we can say that how do we say, uh, we have, for login page we have one code, for welcome text we have another code. Let's say I have a very big blockchain of 10 people, and 10 people have 10 different concepts. One is logging in, the other person is dealing with this welcome text, the other person is dealing with things like maybe ad, or the other person is dealing with the items to be displayed or so. So each person has dealt and put it in a block. So all these are connected in a blockchain, right? I hope I'm clear till here so far. So now when all these blocks are kept in each concept is kept in each block, and they are kept there, when a client comes up to me with his requirements. So let's say he'll say, I want to open a website which will take the detail. I mean, like, I want to open a login page. Once you log in, it should show welcome text, and after that something should be shown, displayed. So here you can see first is predefined contract. Oh wait, I'll just put it to right. Yeah, predefined contract. Here predefined contract. So first thing, the client coming back to this our place to tell what all he needs. Now here business logic, it is nothing but putting up all these together in a way that this should be first for the login page you need to give your details like name, middle name, surname, what is your date of birth or so, all these details. If they are given, then your login page will get created, right? But in the predefined contract, he or she, the client, will only say she needs a login page. But then the predefinition, like what if the condition is what you are supposed to write, that is, if I get the details like name, middle name, surname, age group or whatever, then I can do this, right? So that is the business logic which we come up with in a blockchain. And then execution, putting them all together, and then settlement. So let's discuss a little bit better. So here, link isn't it? Okay. How smart contracts work. Execution process. Smart contracts run on a blockchain networks. That's what we are talking now. Each function is already stored in a particular block, right? And execute automatically when specific conditions coded into them are fulfilled. So as I told, if condition, right? So let's say the thing in the network, all these are already predefined, and when specific conditions are met, we'll talk about that in the next topic, like the next slide. So let's take an example here. A smart contract for a rental agreement could release payment to the landlord once the tenant confirms. So here we can use this example of you booking a hotel in a website. Let's like Agoda or something like some these regular ones, right? Make My Trip or so. So in this, let's say you wanted to book a hotel. So let's say I want to book it from Hyderabad and in Pune. Will the person in Pune even know my face or that I will be booking and he has to put it aside? No, because it's not possible. It's not manually possible. If I have to do it manually, I have to first come to Pune, then go talk to him and do certain set of things, right? And I think that is not humanly possible. So when we talk about this, I am doing like, let's say if I make the payment, then my room is confirmed in the name of like my name or whatever name I've given, right? So here if condition is if payment is made, then only the person in the in Pune, whoever is the hotel owner, will know that this person has booked. If I don't pay the money, and can I say just book it for me and there? No, right? So that is how it works. So if I do something, then that will be confirmed. And is it humanly possible? Like, is it manually possible? No. So that is how these smart contracts work. Yeah. So here, the advantages. First thing, efficiency. So let's say a client comes up to you and different clients come up to you. Is it okay to do it all over again? It's not humanly possible, right? And it's waste of time if you really want to do that as well. So in that way, here efficiency takes place. Like till now, when we spoke about blockchain, we spoke about transparency, we spoke about security, we spoke about trust, and what else? We spoke about immutability, a lot of concepts like this. But all those were not efficient because it has to create a unique ID for everything. It has to be like this, that. But then here, if they are already created with their own blocks in a blockchain, it is very easy for us to access, and you don't have to repeat the same thing again and again. So can we call it as it's efficient? It's a lot efficient, right? It's of course time saving first of all, and then it does it is automatic. The process is done automatically with this main server. Let's say my server is connected to all the servers in a blockchain, and I am trying to create one website. So I simply take all these from those blocks. It's not about anymore about humans. It's more about the systems now. So think about it in a server system, all these terms for better understanding. So let's say I am right here. I want to create a website. I will simply take it from the server or from the computer which has this code. So once I take that code, I arrange it. So it's efficient, right? It's not even wasting my time. I don't have to write it all over again or so. Next, transparency. Transactions are recorded on blockchain, ensuring transparency. Let's say I'm in a big company and I'm connected in a blockchain to all of them. Now, 10 people are assigned one project. And these 10 people, like let's say, have to do one big project with, let's say, website creation again. So, and these 10 people are not like, they never met. Maybe they're working from home and they don't even know who is doing what. If I have a thing like, let's say I took login page and I started it. If let's say everybody wants to start with login page, if 4 to 5 people do the same login page, is it even useful for the project? No. Here, let's say if I took the login page and I started dealing with it, if other person is trying to do the same thing, it will give them an alert that this is already has been taken. So this is one advantage of being transparent. So transparency concepts help you be even more efficient, and you won't repeat the same thing again and again. The third one is trust. As it's not like the client comes to me and I go to some other company. So it's like there are no intermediaries, like there are no many people in between. So let's say I have a blockchain, I'll directly start using my own blockchain to create one. I don't have to go outside and I don't have to trust the other person in order to achieve this. So that concepts I can take as trust. So going to the next one, let's discuss deep into this, how they actually work. So here, the first thing is agreement. Okay. Multiple parties identify the cooperative opportunity and desired outcomes. So, like every person, every client or every person come up with different set of ideas. They want different set of things in their own projects, right? So first, what all are required? See, he or she won't say, I want to take the details of the customer. But then he will say that I should send a message like a welcome message, or I want to send a message to the user that there's a 20% off or so. But then if you want to send it to a user, you can't simply write dear user. You have to write their name to make it more like personal, to go to the customer in a better way, right? So everybody has different ideologies about how they want to make their projects. So here, when the person comes up with an agreement, with a paper agreement, what happens? So we need to identify all of them. What is their requirement? If they have a requirement, set conditions. This means, let's say he or she wants a login page. So for a login page, we need to take the details like the name, middle name, date of birth or so. So when you do that, it's if the set conditions, it will check, the smart contracts will check if we can take the details of, if the login page is required, first thing. Once it will check, the condition is tick marked, right? And then second thing, let's say the client wants something like a welcome message. So for a welcome message, you need a name. So it will check another condition, that is the name present. Do we have the details of the name where we can send a message? Another tick mark. And then here, should we add a cart? So if you need a cart, first thing you need to have items. So to check the conditions in the agreement, do they say that they have the items, that is like to select or buy products? It will check, and then yes, they have. So then again tick mark that you'll have a cart in the website. So here, these two concepts. First thing, identifying the agreement. Whatever has been shared, is it there? Like whatever things they are asking for, what are do they meet our condition set here? do they meet the things which are already predefined in our blockchain? So once these are set, code business logic, it is nothing but setting up in such a way that first thing, login page, complete the login page code, and then next part, that code. So it's like code A, code B, code 3 all together set together. So that is where the code business logic is implemented using the computers. Again, it's not even about the persons, it's a completely server based, blockchain based, computerized part. And then, so already we are using this from blockchain, right? So now the concepts, are going to heat up, and this is where you're going to enjoy the topic as well. That is nothing but encryption and blockchain technology. So whatever you have made, let's say the client is taking all the details of the user. So don't you think it should be super safe, right? It should be super safe. I'll just remove this display. I want you all to make a note of this. I'll continue explaining, but please make a note. Yeah. And so now while we are talking encryption and blockchain technology, right? In this encryption, first of all, your details need to be safe and kept, in a password manner, so that no other outsider will even take the data, right? So that is one. Now, again, once your website is out, whatever, let's say person A has logged in, that needs to be stored, the timestamp, along with the timestamp, and then person B logged in, and then somebody else signed up. All these details should be again kept safely. So again, for that, we are going to use blockchain technology. Even for creating, we are doing, the smart contracts concept. For creating a website, we are using blockchain. And even for keeping it safe, we are using blockchain technology. Once all this is encrypted and the blockchain has been implemented, it is executed and processed. That means we all heard about these testers in software engineering, right? So testers, what do? They check if this is working out or not. They check if there are any bugs or anything that needs to be redid or anything that needs to be changed, or is it meeting the agreement or not. So once this execution process, okay, so when we come back here, encryption provides a secure transfer of message between parties, right? So person A has logged in, that should not be known to person B, right? So if the messages are secure, the transfer is being secured or not. And then execution and processing, the code is executed and outcomes are memorialized. Like let's say the testing is happening around 10 times, right? When it is happening 100 times, every time the outcome should be similar. Like if you do it with this name, the outcome should be like this. Like your first name will be like hi, welcome, hi user one, welcome, right? So is it like always being the same or not? This is one more concept which needs to be taken care of no matter what. And then the last but not the least, it's the network updates. So as it is a blockchain technology, all the nodes on the network update their lectures. So everything happening is updated in the network, where not everybody can access to it, but everybody will know that the transaction took place, like in the blockchain. So it's like a blockchain in blockchain, right? This is one complicated but interesting topic. I want you all to do a little more research on smart contracts and how they work, and come up with 2 to 3 liners about how it can be more efficient and which companies are already using these smart contract concepts or so, right? So coming to that examples, the main thing that uses is Ethereum. This is one more cryptocurrency just like Bitcoin. How many of y'all have heard about this Ethereum? And we also, as we are using the smart contracts, we have one more case study called as Ethereum, as we were discussing before, and where how Ethereum came up with this smart contracts concept into their own cryptocurrency. So it's the leading platform for smart contracts powering decentralized applications. So once we get deep into this one more Ethereum topic, we will discuss about all this as well. And what are the use cases about these smart contracts? Examples from various industries showcasing practical applications of smart contracts. So industries, let's say I am producing a water bottle, okay? So when we are doing this, first thing, there's a piece of plastic that is kept, and then there is air filled in order to expand that plastic. So each process takes place one by one. So if the plastic is placed, then only it is going to expand. Once the bottle is expanded, then only the cap is going to be produced. Once the cap is produced, then only the bottle is going to be filled. Right? So it's like if this is happening, then this will happen. It's similar to the smart contracts concept, right? In industry level, in hardware level. Yes. So this type of smart contracts is also another topic, or another biggest feature of blockchain technology. Right? So that is it about this. So let's see what all we covered in this session about smart contracts or so, right? So give me a minute. Yeah. So yeah, summary, let's summarize, okay? Smart contracts simplify and automate agreements. So do you think we need human intervention again for the same thing to be developed again and again? Like, it's the same thing. So we simply have a blockchain which has all this, and it will arrange itself in such a way that we create something new product out of all the predefined products. So it's super efficient. It's like automated agreement, right? And it increases efficiency and trust, and also it's transparent. Yes. So what is the importance of even learning the smart contracts concept? So it is essential for grasping the potential of blockchain technology, because blockchain technology is not just about transparency, security, decentralization, and trust and all these. Like, it's not just about the unique IDs, it's not just about the hash. There are many other concepts in blockchain technology which will help you do it in an efficient way. So of course this is efficient, right? Let's say all these days, till now, whatever topics we have covered, it's about giving one unique ID and identifying it, producing it or so. But then here, having that unique ID and creating one big blockchain where you can access it whenever you want, makes it super efficient and less time taking, right? So this is one big concept of the blockchain technology here. And just like this, we are going to discuss about more and more. So if you have any questions, please let me know, because this smart contracts topic is very much important. If you have any questions, please put up in the chat box. And if you don't have questions also, please tell me that you don't have any questions. This is a little tricky topic, so it's better if you have even a single doubt or a very silly doubt, it's better you put it in the chat box so that I can answer them. I will give you 2 minutes of time to put up your questions. Please let me know. And if you have no questions also, please let me know that in the chat box. And I hope I'm clear enough. I'll wait. Yeah. Please put up your answers in the chat box. Let me know if you have even a single question. Please put it in the chat box if there are no questions as well. Okay, no question. Clear, ma'am. No questions. Great. I hope I was then. That's great that you're able to understand, because smart contracts concepts is a little tricky. That is the fact. If should we continue with the recap or should we end the session? I just want you to let me know, because we have another 10 minutes of time. After that, you'll have a break. So please let me know No doubts. Okay, great. I'm glad that you're at least responding in a better way. If you have any, if anybody else has any question, so I request you all to please let me know as well. No question, all clear. Great. So I'll be putting up an assignment by today or tomorrow about topics before small recap of the session. Great. Okay, we'll start off with the smart contracts only. We'll take a small recap session. Thank you so much for your things as well. So here, as I was telling, like you'll be having a small assignment till the topics of before the smart contracts part. So please make sure that recap will be helping you and you will answer all those questions. That won't be from the internet, so please try to answer it by yourself. So here, let's just have a recap about the smart contracts only. Smart contracts are nothing but self-executing contracts in terms of agreement. Let's say we come up with one agreement and without any human only, it is going to create all the things which are there in the agreement without any person involving. So it's all literally only the computers working, right? But of course, in order to make the computers work, humans need to initially create one set of things in the part of coding, right? So that is the smart contracts, which is nothing but written in the form of code. Like the things which are need to be done, it is done in the form of coding. So here, smart contracts are digital agreements that automatically execute and enforce the terms of contract with predefined conditions are met. As we were discussing, let's say if the person wants to have a login page, they should be open to accept that they need to take these the details about the person, like about the user, whoever has been using your own thing, right? So that is one. And okay, great. And then let's take a good example, that is a vending machine, and smart contracts always work on these if and else conditions only. So if I insert money, my vending machine will dispense the item whichever I want, right? And just like that it works. If something is done, then this will be like the other one will be executed. That is one big concept of smart contracts. So here we have how it works. This is the basic version, and the next one in the slide is like the bigger version of it. So first thing is predefined contract with whoever the client or whoever is giving you the contract and whatever needs to be taken care of. And then how the business, how do we put it in line, like 1 2 3, we have to put it in series, right, in order to make it clear enough. So that will be the business logic, and execution is nothing but the testing part and settlement. That it is not even our thing. Coming to how they actually work, smart contracts run on blockchain networks. So already the things are there in the blockchain network which are been taken. So it's already a blockchain network, and to that blockchain network which you came and kept all together, you are going to put them in a you're going to put them all again into a blockchain where it is going to benefit all the features of blockchain, right? So when we talk about this, all the things in the blocks in a big chain, whatever blocks are required are been taken. Let's say you need to make a word hat. So let's say there is a blockchain from A to Z. So you take H block, A block and T block. Together you'll put it in line, that is H, after that A, after that T. right? I think that should be a clear example as well. When all these three are kept together, then it makes one single thing, that is hat, right? But this is done automatically. Let's say I want, like you're telling the computer or the server that I want hat, so they'll simply take H, A and T and put it together. So that is how all these are kept. I mean, like they are already taken from the blockchain networks and they are again executed with the help of blockchain. So here the example is, as we were speaking, it's if and else always. A smart contract for a rental agreement could release payments to the landlord once the tenant confirms the recipient of the keys. Here I took an example that is nothing but, let's say you're booking a hotel from your own place to place somewhere far away from you and from an app. If you make the payment or if you confirm the booking, then only your name will be going to the person who is in the hotel. So it's like if condition. And if you give the details only, that person will accept. You can't directly say, like you don't even know this person, right? So can we trust? But if we have this concept, it's very easy for you to trust, right? So this is one. And here the advantages of the smart contract is, first thing, it is efficient. Why? Because it saves lots of time. It's not even like one person, I mean every time you have to do the same thing again and again, and it doesn't require any human intervention or any manual intervention, right? So it's super automatic and it reduces the need of manual intervention. That's what we're discussing about. It automates processes, right? So the next one is transparency. Transactions are recorded on the blockchain. So let's say even to create that particular website or the project, if you take one, it is noted down. Great. And then once you make all together, after you finish the testing and all, it makes sure whatever transactions or whatever whoever is logging in or whatever is happening in that particular thing, that also is noted down. And as it is immutable, nobody can change it once it is happened. So your data is safe and nobody can change it. The thing is trust. As it's a blockchain process and you don't need to believe on one person to do the thing what you want, or you don't need a person or party or an intermediate person to help you complete your own project. You simply give it to the blockchain, you simply get it done, and none. You don't have to trust a person, you don't have to rely on other people, and it's easy. So that is about the features and advantages. And the last thing is how smart contracts work. First thing, it identifies whatever is given in the agreement. Once it is identified, it checks if it is meeting our conditions which we have already stored in our blockchain. Once the conditions are also set and everything is like, if the person wants login page, he needs to have the details about that, about the user. So yes, the user details are required, yes, a tick mark, and then what else is required, that is a tick mark. So once all these are verified through the systems, then the core business logic, that is nothing but everything is kept in line, one by one. And like A, B, it's put it in, like let's say we are making a word matter, MATTER. So is it kept like M, A, then T, T, like is it kept in line or not? So that comes under code business logic. And once you made it, you have to encrypt it again using blockchain technology. And once you encrypt it again, you have to note down in the point of blockchain technology only, right? Like to keep everything safe, transparent, and everything should be made a note of, right? So that is one more. And then execution and processing, that is nothing but that comes under testing, where all the outcomes should be similar and it should be noted down. And once this is done, it is directly sent to the networks where everybody can use it using blockchain technology. Great. So the real world example is nothing but Ethereum. Maybe you can come up with one paragraph about Ethereum, how it is using this concept of smart contracts and decentralized applications. So that's it for this session about smart contracts. You can even come up with the daily world examples. It doesn't have to be completely Ethereum. As I was telling, it's an industry and I took an example of a bottle industry. You can also come up with many examples in the same way. So I think this is clear. If you have any questions, please put it up. And after 4 minutes, I will be ending the session because 12 o'clock you have a break or so. So please let me know if you have any questions and it's clear or not. I consider there are no questions only and everything is clear. Cleared, ma'am. Great. Thank you so much. So I think I'll be ending the session. I'll just wait for one more minute. Please let me know if you have any questions even in that minute. And if there are no questions, then I will end the session. We'll be meeting again with a detailed way of smart contracts. So you can take your break and please come back on time for the next session about cloud computing. Thank you.
Welcome to the next lecture in the computer network series. Today we will see the part 1 of the OSI reference model. We will see the outcomes. The learner will be able to understand the OSI reference model. We will list
Welcome, my fellow
Yeah, good afternoon everyone. Welcome back for our next session. I hope you are all there here with me. Yes, good afternoon. So if you can quickly interact with me through the chat if you are there, so that we can quickly jump into our session now. It's very interesting and it's very important session for us. So I hope you are there. If you are there, please respond in the chat yes. I just want your response that you are there, you are listening to the class, so that I can continue start this session. Okay, I guess few of you are with me. So I just want to recap a small recap of yesterday and what we have done from past 4 days. I don't know how many of you are there with me from past 4 days. Okay, I'll just recap what we have done from the past days so that I can relate this topic to what we have learned and how this topic is going to help us and how can we use this topic for the future sessions as well. So let's just recapping of from the first day. We just started with the computer. What is computer exactly? How we are going to work, and then we just slowly moved into what is data, what is information, how the data and information are different. Yes, we have done with few examples also, and then we slowly entered into networking. What is internet, how the internet is defined, and how we use the internet, what is the benefits, what are the uses of internet. With that information we slowly deep down into cloud computing, and the first thing what we learned in the cloud computing is what is cloud computing, how the cloud computing helps us, what is the difference between normal computer and the cloud computing. And we also see some from past few decades what is the computer, how computer started, and nowadays how we are using computers. And then we also saw that how the data, how the storages are there, and we learned about different types of storages, how the storages are provided by the cloud providers. And we also learned about what is the different storages are given by the cloud providers, where exactly the storage is stored when we use those applications provided by the cloud. Yes, and we also differentiated different types of clouds like what we say Azure, Microsoft, Amazon, Google, very popular clouds. And we learnt about different cloud services as well as cloud models. Anyone tell me, I have question, what are the different cloud services we have in the cloud computing? I just need quick response from you. How many are there and what are the services? These small questions I want to know, at least you are listening to the class and you are getting something out of these lectures. without you are getting something out of these lectures, waste of taking these lectures, right? So that is the reason I want to ask few small questions from the last previous classes. Yes, I want to answer for this question. What are the cloud services we have, and how many we have, and what are those cloud services? No, OneDrive, Google Drive, or the storage services which are given by the Dropbox. Yeah, these are all the services given by the cloud providers, but we have something called service models. We have different types of service models which is provided by the cloud. Yes, exactly. I got an answer. Infrastructure as a cloud, platform as a cloud, and software as a cloud. Good that I'm getting answers from you so that I can know that you are there in the classes and you are listening. I have one more question. What are the different cloud models we have? What are the different cloud models we have? Yes, anyone? What are the cloud models we have? We have primary cloud models, we have combined cloud models. What are those? Okay, I'm not getting any responses from you. So it's okay. I'll start my today's session. I'll start my today's session with the understanding of types of cloud models also. So today's session is all about understanding the importance of data security and privacy. At least answer for today's session, because I need how much you know about these two things and today's lecture, so that I can adjust myself and I can teach you at what level I need to teach you. So first I'll tell you what are the cloud models we have. So we have different types of cloud models. We have public cloud, we have private cloud, okay, we have hybrid cloud, and we have multi-cloud. So every cloud model have different kind of working. So public model is all about giving the public information that everyone can access. And when it comes to private, the private model is all about giving the access to the few specified identities. So it is nothing but, it can be a one person, it can be a two person, it can be a community of people, but the restriction is there, only few people can access this cloud. And hybrid cloud is nothing but combination of private and public cloud. Okay, and we also have one more thing, community cloud. That community cloud is nothing but the cloud services given by the cloud providers can be accessed and can be used by only that specified community. When it comes to multi-cloud is a combination of hybrid cloud and community cloud. In this cloud, what will happen? There will be two different sessions where part of the information can be accessed by the public, part of the information can be accessed by the only private persons, which is nothing but specified persons, and the part of the information can be accessed with the community of people, which is given to the specified community. So that is what these all clouds. So with this understanding, I just want to ask you a question. What is the difference between security and privacy? Please, I need responses from you. What is the difference between privacy and security? If you answer only, I can move forward. So what is the difference between privacy and security? Waiting for your responses, because I need to understand, at least you know what is the difference between privacy and security. What is privacy? What is security? Keeping our data secure from malware is security. Privacy is charting only. No need security too much. Okay. Security, protecting of information. Okay. Yeah, I'm getting a few good answers from you. So let's get into the topic. I'll tell you what is cloud privacy, what is cloud security. Right to manage personal management. Okay. Yes, true. So privacy is managing your personal information and security is protecting your personal information. Good answer. I got good answer. So going to the topic, whereas cloud, let's say with example, cloud, we are not storing our data in our physical devices, right? So we are storing our data in someone else's devices, someone else's storage, and we are accessing the data, or we are what we can say retrieve or push the data through some networks. Yes, how can we access cloud? How can we access Google Drive? How can we access what we can say Google Photos or something? We can only access through the networks, right? So the privacy is nothing but safeguarding your data. Yes, when you are putting in the cloud, or if we say when you are transforming your data from your system to cloud, there can be some leakages. Yes, there someone can misuse your data. Yes, someone on a, let's say there is one organization, only few people can access that. So what if some unauthorized person can access that, and if let's say they can take the data, so that is breach of privacy, right? So privacy is nothing but keeping our data safeguard from different attacks, which is leakage, misuse of data, which is breach of privacy, or what we can say, unauthorized people can access our data. So this is privacy. So unauthorized people, how they can access our data is, let's say when we are uploading our photos or some data from your device to a cloud storage, there will be intermediate phases to go to the cloud storage. We can directly not access, or we can directly store our data in cloud. There are some intermediate phases. So what will happen? Someone can attack in the middle of the data pipeline. Okay, because we are not sending data through something. Yes, we are sharing the data through network. It might be a physical or it might be a signal, like which is virtual. So when we are, let's say for example, when we are connecting our power from transformer to our home, if someone connects in the middle of the wire and get current to their home as well, so at that particular time what will happen, the load increases, right? So they are getting data from our privacy of data. So whatever the connection is given to our home is our private property, right? So if someone is entering in the middle and getting that power to their home, that is called breach of privacy. They are taking our data. That's what happens when we are sharing or retrieving data from cloud. Someone can attack in the middle of service, which is sharing or retrieving data. They can access that data and they can use it. That is happens in the cloud privacy. So to keep private the data, security comes into the picture. What is security means? We are protecting the data. We are protecting the data which is stored in there. Yes, when we are storing the data in someone else, the data is not with us. We don't know what they can do that data. So to protect that data, we have security. So it can be in rest or it can be moving in or out of the cloud. Okay, that is called in motion. So we have two functions. One is keeping the data in rest. One is keeping the data move in or move out of the cloud. Move in or move out of the cloud is nothing but when we are uploading photos to the Google Drive, that is called move in. When we are downloading the photos from the Google Drive, that is called move out. So when we are downloading or when we are uploading photos, someone can access the data. To keep it private, we use security. Security from threats, unauthorized access from someone else, or what we can say, corruption of data we say. Yes. So to avoid these all things, we have security. So I'll show you more deep about this security and privacy. So what is data security in cloud computing? So what is the thing is, let's say we have image here, right? So look into this image. Whatever we have this cloud, this total cloud is a storage where we are storing our data. Okay, let's say we are the organization. So when we are the organization, we'll have some specific access to the data only for the specified people who are from the organization. So these all end users are the people who can access the data, who have the access to data. So this external audit party is nothing but some threats, some thieves who are interrupting between the network. Yes, let's say we are using some network to store the data, to activate or to do some functionalities through the cloud. what these external audits can do, they can interrupt between the process of retrieving and uploading the data, and they can also access the data. So to these all things, to avoid these external audit parties to get the data, to retrieve the data, or when we are using the data, they will also know what we are using, what we are doing. So to do all these things, we use called security. How we can protect that from the security, we'll see now. So what are the common cloud security risk means? Internal and external threats, okay, cloud breaches, visibility and control limits. Visibility and control limits is nothing but, let's say last session I told you, when we are using Google Docs or some cloud applications, we have Google Slides, Microsoft Word, we have cloud applications. When we are working as a team, when we develop or when we do a application and when we share that application, we have something restrictions there. Yes, we have restrictions like only share with these people. There is also one thing called that document can be accessed to anyone. And we also have the person who can access. There are some limits for the user. That limits are only to view, only to write the comments, and only to ownership. So these all things, what it can do, the visibility and control limits is, that's what the visibility and control limits. Visibility is nothing but anyone can see that data. Let's say example, we have Google. The data which is in the Google, that anyone can access, anyone can see the data, right? But there are limitations when we go for some few things like, we have database, that database we store our company data. So when we are storing our company data, there are limits whom to give access and what access we need to give. That is called controlling limits. Okay, what we say, there are a team of people who are in the same organization, where one person is the admin for that. We'll give the control limit. That person can do anything. He can read, he can edit, he can comment, he can access any data. Where it goes to developers, there is some certain limits we'll give for the developers. The developer can only access what they want to do, or the developer can only comment what changes can be done. So these are the limits we'll give for few people to protect our data. So that is the common security we need to take. Without that, there is a lot of risk in the cloud. And one thing, there is internal and external threats. So what is internal and external threats means? Before we access the cloud data, what we say, someone shared us some message or some mail, we got a link. So those links, what they will do, if we click on the links and if we open the links, they can easily access our data and they can easily access our whole system, what we are doing, and they can see what we are doing and what data is stored in our clouds. So that internal and external threats can be controlled by the security. When we are accessing, when we are opening mails, or when we have spam mails, we have trash, these all things are there. So when we are opening that, we'll get a warning that if you are opening, there might be this threat. Someone else can access you. So that is the major common cloud security risk we have. So to protect all those things, we need to maintain some security in different layers of data. So that I'll show you later what data, how we do that. So just tell me any doubts till now so that I can continue, because this is very interesting topic and very tough topic to understand different concepts. we are slowly going into the deep, so I'll go very slow. I just want to know everyone is on same page, everyone is understanding what I am teaching. Yes, I need response. Any doubts till now? Till here, if you have any doubts, let's discuss through the chat, so I can help you. That also helps others. So I'll give 2 minutes for your doubt session. So till now, if you have any doubts, ask the doubts. If you don't have any doubts, tell that no doubts, so I can continue for the future. I hope all clear. So I'll continue the session. So how can we protect our data? How can we see when we don't know whom can access from where they are accessing, but there are some things where we can protect our data. So I'll tell you how can we secure or how can we do that. So consistent security updates means, I'll give simple example where the threats can happen to access our data. Let's say we have an Android phone which is developed by one company. Let's say one company, X company is developed. So when we bought that mobile phone, they'll give mobile phone with one kind of software, 14 point software or 14.1. So we have versions of software available in market. So when we bought that mobile, we have software 14.0 which is given with the phone. So later on what will happen, when we buy that phone, we'll have few functionalities which are working. So when after 6 months or 5 months, the software will update, yes or no? The software will update. So at that time, if we are not updating the software, whenever they update software, what the X company will do, they will change few things in the software. They will add something, or they will remove something, or they will modify something. Say for example, we took one small example. In the Android phones, the notification bar, when I bought my phone, when I buy my phone in the 3 months back, for example, so they gave notification bar which comes from the side, okay, and later on what happens, when they updated, they change that notification bar which comes from the top, okay. So I didn't updated it, still I am getting notification from side. So the problem is, whenever they update the software, okay, whenever they update the software, they need some modules to be added, they need to remove some modules, right? So at that particular time what happens, they will add security to software. It can be different layers. Security we can add in different layers. So they added the security for the notification bar which comes from the top, so that no one can access our notification bar, so that our data will be safe. So I didn't updated it, so still I am getting old software. So the problem is, whenever we are not updating the softwares, they will not have a security for the old softwares, because they updated it, so they definitely want everyone to shift to the new software, but we still didn't updated it. So at that particular time what happens, the security will be removed from the old notification bar. So whenever we are getting a notification, the notification information before we receive it, it will traveling from the network. It will traveling from the network. So if someone attacks our mobile notification bar module, what will happen? Whatever the data we are getting from the notification, they can access it. Because there is no security, there is no protection for us when we are getting notification. So that is the reason whatever the software, not only the mobile phones, if you take any application regularly or year in a while or 6 months a while, we'll get some updates. So that is what we need to consistently updates to make sure to keep our data secure. And also what says we have a Wi-Fi in the campus. Let's say Assam campus is the example. So we have a Wi-Fi. So that Wi-Fi can be accessed the person who is in the Assam campus. There is some frequency limit where the Wi-Fi can be accessed. So the problem is, before getting the Wi-Fi to the Assam campus, we are getting that network from the network provider. So in between that, if we don't have any firewalls, anyone know what is firewall? Please let me know through the chat what is firewall. Yes. What is firewall? Okay, I'll tell you what is firewall. So firewall is a security software. Firewall is a security software, security system, we call a system. That system will protect our data or our information by notifying that who are the input, like who are the users coming and going out. Okay, so let's say we in the Assam campus, let's say the students and the faculty, they have created, everyone created mail ID only for the specific Assam people. So what will happen when the person from the other mail accessing the Wi-Fi, it will notify that someone unauthorized person is accessing our data. Wi-Fi is also a data, right? So through Wi-Fi what we can do, we can we can access the Wi-Fi. Through the Wi-Fi we can access who are using Wi-Fi and what they are doing with the help of Wi-Fi, what information they are transferring or what the information they are doing. So that can also possible. So these firewalls, it will do, these firewalls will protect our data by checking who are the users coming in, who are the users using our Wi-Fi, and who are the person who has access to this Wi-Fi. So these all things can be restricted by the firewalls. It is very difficult by sitting there and who are accessing Wi-Fi, who are connected. So these firewalls will automatically stop if the unauthorized person access our Wi-Fi. So that is how the firewalls will help us. So what we will do in the intermediate, before getting the data from the server to the Wi-Fi which is in our campus, we will put a Wi-Fi firewall between network provider and user. So what it will do, it will restrict only few people to access our Wi-Fi. So that is how these firewalls will help us. And redundancy is nothing but let's say we are saving our data in one Google cloud. Okay, so there also will have own physical storage devices. We can't save online, right? We need everything to be stored in the physically. So we are storing in their storages where they will store in their physical devices. So it's, let's say if they are putting their physical storage at only one place. Let's say they are putting their storage in Pune. Okay. So if something short circuit or something blast or something happened to that particular storage area, if they store only our data in only one particular storage space, our data is gone because there is no backup. So for that reason, the cloud providers, what they will do, they will store our data in more than one physical storage devices. Let's say I stored 15 GB of data in Google Cloud. They will store my 15 GB, one in India, in Pune, and they will also store one in America, in some other storage space, and they can also store my data in some other space also, where is in Europe, which is UK or somewhere. Because something happened here, I can use the data by accessing data from other spaces. We have backup, right? So that is how we need to protect our data. So that is called redundancy, that is backupping our data. And third party security testing means whenever we are downloading something, there will get some security issues. This is malfunction software, this will attack your system, this will attack your data. So we need to test it, we need to check it, will it really attack our data or will it not. So that is how the cloud providers will check each and everything to keep our data safe, and they will protect our data. I hope you understand these all concepts, how cloud providers will protect your data. With this understanding, I'll get into what is the importance of data privacy. There are different things to keep in mind when we are playing with data. Playing nothing but when we are using the data. I'll start from the ethical responses. Let's say when I am joining in an organization, first day of joining, they'll give some paper, some paper to sign there. I will not share this data, what is happening in the company, to anyone else from the outside of company. So that bond we need to submit to company, because ethical response is nothing but we have ethics. For every individuality we have ethics, which is nothing but we can't force them to reveal their privacy to others. The same way for the company also, the company data is their privacy, their ethics, not to share with someone else. So that responsibility is there for every individual who are working for the company. If it is legal complications, for example, same for the company, when we are signing there, we need to sign on some legal bonds there, that if I do this, you can do this. For example, if I share data with someone else, you can remove me from your company, or you can file a case on me. Those things will be signed there, which is legally we can share it, but illegally we can't share this with someone else. For example, if you take protecting personal information is, let's say we have a Google account. For every Google account, we know we'll get 15 GB of data free. So if you buy or if you use only 15 GB, that data which is provided for the Google account, which is private data, that is personal information, right? So we have an authority, we have an access to protect our personal information, because when we use a cloud applications like cloud apps, for example Google Cloud apps, we say Google Sheets, Google Docs, we have an access whom to restrict, whom to share the document. Yesterday we saw that when we are using the Google Docs or Google Sheets, there we have only share with few people. That few people also we can give what access we want. Those things we have on protecting our personal information. If we want to share with someone, we can give access. If don't want to share with someone, we can restrict that access. So this is the privacy we need to take. These are the importance of data privacy. I hope you understand till now. This is a basic platform to understand deep into the security and privacy. So if you have any questions, please ask your questions. So I'll take 5 minutes or maybe 3 minutes. So with that understanding, we can go into deep. Before going in, I just want to know any doubts. After this, I'll show you one video and then I'll jump into the topic. I'll wait for more 2 minutes. If you have any doubts, ask so that I can clarify your doubts, because it is very interesting topic. At the same time, it is very hard to understand the topic. We need to clearly listen to the lecture, or we need to be focused. So I'll wait for more 2 minutes. I'm not getting any responses, so that I can confirm that no doubts or you didn't understand anything. Okay, I feel that no doubts. With this, I'll show you one small video so that you will get a very clear understanding of this thing. So before starting video, I'll tell you something called, we have something called OSI layers. Someone know what is OSI layers? What is the full form of OSI layers?
See the outcomes of today's session. Upon the completion of this session, the learner will be able to understand the OSI reference model. We will list various layers in the OSI reference model, and we will understand how each layers interact with other layers. Before we start, we will see what is layering again. Layering means decomposing the problem of building a computer network into more manageable components, and we call these manageable components as layers. So the problem of building a computer network, it is a big one. So we are decomposing that into smaller ones, which we call as layers. We have two benefits. One, it provides modular design, and number two, it is easy to troubleshoot. Now we will move on to the purpose of the OSI reference model. The purpose of the OSI model is to facilitate communication between two systems. When I say two systems, it means two different systems without requiring changes to the logic of the underlying hardware and software. I will elaborate it now. We are going to establish communication between two different systems. Two different systems means two different computers with two different operating systems, even two different devices with two different functionalities. So, in terms of hardware also they may be different, in terms of software also they may be different. So, two different systems are going to communicate with each other with the help of or with the guidelines provided by the OSI model, so that we don't require any changes to the logic of the underlying hardware and software. Now we will see what are the various layers in the OSI reference model. Basically, there are 7 layers in the OSI reference model. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. As far as OSI reference model is concerned, the order of the layers are very important. So we should not change the order of the layers. It is a very important question for your examinations also. So the order of the layers is very important. So how to remember the layers without changing the orders? I will just provide you a shortcut now. Just note this sentence. Please do not throw sausage pizza away. P for physical layer, D for data link layer, N for network layer, T for transport layer, S for session layer, P for presentation layer, and A for application layer. When we remember this sentence, we can easily remember this layer, the order of the layers without changing it. There may be a small confusion only. There are two P's, P here and P here. So the last one is always physical layer. Always remember this, the last one is the physical layer. Now we will see how each layer interact with other layers. In this scenario, there are two devices, device A and device B. And these two devices are connected to a network, and there are some intermediary nodes that this is a router and this is also a router. And when the data wants to move from this computer to this computer, so the data, whatever this computer is generating, has to be placed on this line or this cable. So before placing on this cable, so it has to go through all these 7 layers, and finally this physical layer only places the data on the cable. The user who is sitting at this place will open an application, and that application only is going to generate the data. The data generated by the application layer is handed over to the presentation layer, and then presentation layer hands over the data to the session layer. Then comes the very important layer, the transport layer, and then the data is handed over to the transport layer. After transport layer, the data is then handed over to the network layer. Then it is given to the data link layer. Then finally it goes to the physical layer. If you observe, each layer has its own set of functionalities. In today's session, we are not going to deal with the set of functionalities of each layer. The main focus of today's lecture is to remember the OSI reference model and its layer. And these intermediary nodes will process the data pertaining to only 3 layers, that is physical layer, data link layer, network layer. Because we don't want the application data to be accessed by the routers. If someone does that, then obviously he is an attacker or a bad guy. So we don't want any intermediary node to access application layer data. So always remember, the intermediary node will focus only on physical layer, data link layer, and network layer. And finally, whatever the data is received, it will be given to the physical layer, then it is given to the data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The data generated by the device or the source computer will be from layer 7 to layer 1. Upon reception of the data will be processed from layer 1 to layer 7. Always remember, layer 1 means it is physical layer, layer 2 means data link layer, layer 3 means network layer, layer 4 means transport layer, 5 session layer, 6 presentation layer, and layer 7 application layer. And always there will be an interaction between the adjacent layers. That is, presentation layer is going to interact with this application layer, and this presentation layer can also interact with session layer, because if this is the sender, it should go like this, like from 7 to 1. But if this is the receiver, it takes the data from 1 to 7. So always there will be an interaction between the adjacent layers. Example, transport layer can interact with network layer as well as to the session layer. So this is how the interaction is made. Now we will see how the syllabus is framed. Chapter 1 deals with the fundamentals and the physical layer. So this is chapter 1. And chapter 2 deals with the data link layer. So this is the data link layer.
I hope you got something from that video. What exactly the OSI layer, what are the things will be kept in the between the two different layers, what exactly the information, which type of information is passing through the layers. So with that information, I'll tell you, explain what exactly each layer works. So I'll start with the layers are bottom to top, but when we are using the layers work from top to bottom. Okay, so I'll start with the application layer, which is the topmost layer. So this application layer is nothing but which process the applications in the network. Okay, so for example, I opened 3 tabs. Let's say 3 tabs I opened. So in the 3 tabs, I'm doing simultaneous work. So I'm sending some data through the WhatsApp. I'm sending some data through some other application, and I am using some more data through some other application. So these are applications which runs and which process the applications in the network. That is called application layer. And the next layer is presentation layer. So this presentation layer, for example, we say when we are chatting in the WhatsApp. Let's say we are chatting in the WhatsApp. So there will be 2 users. One is sender and one is receiver. So what this presentation layer will do, whatever the data which is sending, it will recognize what type of data they are sending, and it will encrypt the data. The only person can visit the data is sender, and once the receiver receives, and the receiver, what data is there, it will not shown to anyone who are between the sender and receiver. So that is called presentation layer, which is like encryption of decryption of data will be there. So that encryption and decryption of data will access, and which will shown only the presenter and receiver. So that is called presentation layer. And next we go for the session layer. In this session layer, what will happens, let's say we have different things, like we say, what we can say, when we are sharing the data, there will be a communication between 2 routers. Okay, so when we are doing different applications, what the network know, what application you are doing. So if you are using WhatsApp, the router knows, okay, he is using WhatsApp, so I need to use that protocol to send this message to someone who we want to send. That messages will transfer from the routers with the help of IP addresses. That IP address comes in the bottom. So this helps us to understand what application we are using, because we are not using one application in the browser, we are using 3 applications. So when we are using 3 applications, 3 types of data will be transferred, right? So when the 3 types of data is transferring, this session layer will know what application we are using, so that what the session layer needs to do. So that is what inter-host communication between two different applications. Next we'll go for transport layer. This transport layer, there are two types of communication: one-way communication and two-way communication, which is TCP, UDP, SSL, TSL. These are the types of communications. So when it is two types of communication, when we send the data, once a receiver receives the data, we need to get the notification that he receives the data. There is only one-way communication in some applications. Something will browse and we will see the data. That's it. For example, two types of data communication is, one is WhatsApp. When we send the data, once a receiver receives, we'll get a receiver notification. Okay, double click. Okay, he on the network, so that he receives the data. Once we see he or she see the data, we'll get a blue mark. Okay, he is able to open the data. So that is two-way communication. When it comes to one-way communication, one streaming application, let's say Jio Cinema, which is streaming IPL. Whatever the data is coming from there, we are just watching it. We are not sending any information that we receive the data, we are able to see the data. So the transporting from end to end, we have different forms of transporting, but transferring from one end to another end, there comes to the transport layer. And next comes the network layer. This network layer, what it will do, it helps. I am sending from one network, I'll have one IP address. I am sending to one more network with the IP address. So the network layer, there are routers. In between networks, we have routers. So I'll send the data in the form of packets. So once I send the data form of packets, the router will receive the data. Once the router receives the data, it knows, okay, from this network, the information is getting. And from that network, the user want to send this information for the next network. So this network layer will divide which network we are using and to what network we are sending. So after this, it will have a clarity. So okay, he want to send from this IP address and he want to send it to something called, which is the receiver IP address. So this IP address will have some amount of data. That data we call as 1500 bytes. Yeah, I think 1500 bytes. So 1500 bytes of data will receive from the IP address or transform from the IP address at one time. Okay, that 1500 bytes of data will transform at a time. And again the receiver also receives 1500 bytes of data at a time. And the next we have data link layer. So that data link layer, we have physically addressing the, so we have Assam campus Wi-Fi. Till Assam campus Wi-Fi, we have network layer. Okay, so okay, sender uses some outside Airtel network and the receiver using Assam campus network. So from the sender to receiver, we need to send outside network to the Assam campus network. So in that Assam campus network, how the network knows to which system or to which person we need to send the data. That is how we have a MAC ports. We call as a MAC. So that ports will have different unique ports for the different systems. Each system has its own MAC ID. While they are building their devices only, they'll build the MAC IDs. So adding that 1500 bytes plus add on MAC ID, it is 15 bytes I think. So it is around 14 bytes. Yeah, it is around 14 bytes. Data will be shared to the particular MAC ID address. Once we send the data, coming from the application, presentation, sessional, transport and network, in the data link layer, it goes to the specific person. Till the network layer, it is only moving in the network. But when it comes to the data, it will go to the specific person whom we are sending. And next we have a physical layer. So so we got to know till data link layer, it have MAC address. So the data is transferred to that particular system. So how we'll get that particular data to particular device? Something we have called physical connections, right? From CPU to monitor, CPU to mouse, CPU to keyboard, we have physical connections. Anyone know what is the computer language? What is how the data is shown in the computer? What is the computer language? I won't answer for this question. It's a very basic question. What is the computer language? How the data will enter into the computer and how the data process in the computer. Okay, so the computer language is in the form of bytes. Bytes are nothing but on and off. If it is off, it is 0. If it is on, it is 1. 1 and 0 are the binary numbers, binary we use for the computer language. So that bytes will share you what exactly the data is shared from the sender and what exactly we receive. Once we receive the data, we'll again retrieve back to the sender that I receive. That is two-way communication protocol. There are also one-way communication protocols where we only receive the data. So these are the basic structure of OSI layers. So in these layers we have something called encryption and decryption. What others cannot see, only the sender and receiver sees the data that is present in the presentation layer. So these are the layers we have. I hope you are clear with this. Please let me know through the charts if you have any doubt in these all session layers or any other doubts from the top, from the starting of this session. Please let me know, then only I can go forward, because it's very important, it's very deep to know. So please let me know if you have any doubts. I'll wait for 5 minutes. Layers or any doubt you didn't understand, please ask me through the chat. I can help you. Yes, I feel no doubts or nothing is. You got nothing, please. Okay, I feel you are not ready to ask doubts. So this is the 7 layers we have. So the final physical layer will sense the data from the network to the system or to the device through the connections which are physically connected, and that physically connected will send the data in the form of binary numbers, that is called binary transaction. I hope you understand. So for today's session I want to stop here itself, because if I go more you will not understand anything. So now it's time for Q&A. If you have any doubts, please ask. If you don't have any doubts, just say no doubts so that I can end the session. I'm waiting for your responses. I'll wait for 5 minutes. If you have any doubts, please ask. If you don't have any doubts, just at least say no doubts so that I can wind the session. No doubts. So everyone is responding that no doubts. So with this, I'll end this today's session. We'll get into more deep where the security and privacy used in these 7 layers, how it is related to cloud computing and all. So, okay. Thank you for everyone. Thank you.